would like to welcome Don Box.
Thank you, sir.
Oh. Great. So, thanks for having me, Chris. Thanks for inviting me to the conference, letting me give a talk. What I want to talk about is I started a new book a few weekends ago, and this talk is basically the first chapter of the book. So I'm going from town to town, village to village, with ringing my bell, telling this story as I write it down, because every time I tell it, it makes it easier to write it. So in essence, you guys are just doing me a favor by humoring me and just sitting there while I basically read it's like a poetry reading, right? All we need is the black turtlenecks and the lattes, and we'd be completely done. So this is effectively a reading from my book. Let's get started. Brad Cox was a visionary. How many people know who Brad Cox is? Back in the 80s, he was a significant figure in the world of object orientation. Brad Cox did two things that were really, really influential. First, he invented this thing called Objective-C, which if you program Cocoa on the Mac OS X, you are using Brad Cox's goop because that language is his language. Objective-C was an attempt to add object orientation to C in a way that didn't suck. And of course, that meant it lost, right? He also wrote a book called Object-Oriented Programming: An Evolutionary Approach, which I would actually argue was more influential, right? Objective-C was a very niche language until the last couple of years when Apple basically brought it back to life. But a lot of people read the Cox book back in the 80s. And the whole metaphor of the Cox book was that objects were good, object orientation was good, that what it enabled, what object orientation promised to the software development world was this notion of a software integrated circuit. Right? People in the software world are always looking to the hardware world for analogies because for some reason they're considered more credible, right? That they're a hard science. Software is for the failed journalism folks, who kind of liked technology but not enough to actually take physics, right? And so we love analogies to the hardware world because it makes us feel like real engineers and real scientists, right? And so Cox made this great analogy that object orientation would allow software developers, programmers, we used to call programmers, made less money. Actually, that's another story. But programmers would basically be able to manufacture components, software ICs, that could be plugged into new scenarios that perhaps wasn't anticipated by the original developer of the object. Right? That was the whole metaphor. People poo-pooed him, back in the 1980s, especially the early 80s, people said this object thing will never fly. There were the, Jordan folks who thought, structured programming, hypo diagrams, all that stuff's the last thing we ever need. It's the last good idea. Thank you very much. We made our nut on that, so let's not do anything new. And of course, all the perf folks looked at this stuff and said, my God, it's not C, right? My God, you're adding a level of indirection to a function call. My God, that's going to suck, right? So there's a lot of skepticism back in the 90s. It seems ridiculous now. I mean, everybody kind of takes objects as for granted. It's heresy to say anything negative about them. Cox was absolutely correct, though, that objects have become the moral equivalent of a software integrated circuit. And that carries with it a lot. And it's not all... It's interesting to look at the way ICs work. One of the interesting things about integrated circuits is that they are small, they are fast, there's no penalty. In fact, there's a performance benefit for going from an old system of discrete transistors to TTL or CMOS-based IC world, right? That it was actually good. It was enabling, right? It enabled us to build new hardware devices that we couldn't build otherwise with just transistors. I mean, imagine the Pentium 4, with all three-legged transistors with the tab on it, right? It would require some serious cooling. Not that what they built didn't, but that's another story, right? Well, objects have evolved. The industry got behind this thing, right? The industry said, well, maybe it's a good idea, and we want to sell people the same shit over again, so whatever, right? So everybody got behind objects, and the industry focused its attention on making objects good, on making experience a good experience for everyone, not developers, but for users. And objects, the fundamental premise of object orientation is that abstraction is cheap. That is, making new abstractions is in fact the primary task of the object-oriented programmer. It is not to write programs. It is not to write code. It is to create new abstractions. And we have compiler experts and runtime experts and chip architecture experts who get together to make these abstractions no cost, or as low cost as humanly possible. Few people really worry much at this point in time about the cost of a virtual method call, right? Is it real? Yes. Can you measure it? Yes. The benefit you get from the flexibility of virtual method calls outweigh the micro-optimization you get when you turn it off? Yes, especially when you consider the fact that if I'm calling across DLLs, it's the same cost anyway. Right? That was the thing we found out in COM, was that the cost of making a COM method call was really no different than the cost of making a call through an IAT and all the fix-ups, right? Especially if you got relocated. So people don't really think about the cost of abstraction anymore. In fact, that's good. The object-oriented world was basically to lower the cost of fabrication, right? ICs were able to overtake transistors because it was cheaper to make them, right? It was actually lower cost engineering and manufacturing. Same thing happened in objects, right? Basically what happens is every developer who uses an object-oriented programming language is a chip fabrication plant, right? The fact that we don't make you wear the white hairnet while you're coding escapes me, right? That may come soon, right?
I do wear one.
Great, glad to know that, Dave. Thanks for sharing. So, object orientation is about making abstraction cheap. We have runtimes, compilers, goop all over the place. People focused on making it go fast. And in general, the only thing kind of left that is really bothering people about object orientation is the relative primitive state of garbage collection. Right now that we've shot C++ in the head for most professional developers, people are having to get used to garbage collection, and the garbage collector state of the practice is, a little bit behind virtual method call invocation, right? But give it 5 years and again, you won't notice it. So, abstraction in an object-oriented system is good. It is the way we manufacture ICs. It is the way we put ICs together. What do we know about the way ICs are used? Well, it's easy. Every integrated circuit goes into something called an IC socket. And if the IC you bought doesn't work the way you want it to, you remove the IC with a chip puller, and you go down to the Radio Shack, and you buy a new 7404 gate, and you drop it back into the socket, reboot the piece of hardware, and it all works just fine. Isn't that the way ICs work? No, that is not the way ICs work today. That is the way ICs worked in the 1970s and maybe part of the 1980s. Right? Today, what do we do with integrated circuits? We have this thing. It's an amazing substance. It's called solder. Today, integrated circuits are soldered to printed circuit boards. Did you know this? right? If you open up your typical hardware device, you don't see an integrated circuit in a socket anymore, except the CPU. And that's only because the evolution and the price pressure of CPU churn makes it impractical to solder that to the board. So it's the one piece left that we actually don't solder to most modern computers, although there are motherboards that come with like Celerons and low-end things that are actually soldered to the board, right? But the average user does not do field replacement at the IC level anymore, right? Very, very few people, and no one who gets laid, actually replaces the CPU in their computer. And because the people who do not get laid, they will not reproduce, so time will take care of them. So, what do we take from this? Cox was right. We have a technology for building the moral equivalent of the integrated circuit. And the way we build systems with integrated circuits is we solder them. And object orientation is a wonderful metaphor when you are using solder. It lowers manufacturing cost, that is development cost. It is very efficient. It allows you to build things you couldn't build any other way because it helps you manage complexity. But don't fool yourself. Objects were not meant for field replacement. Object orientation is not a good metaphor if I need a socket. If I need an IC socket, there's some issues. And the issues are, if I'm going to do field replacement, that is, if people other than the people who wrote the code are going to be integrating the code over time, long after these people have died or gone on to some other project or have, churned their IPO money and, have gone on to do something else. It turns out that abstraction, which is the fundamental metaphor for object orientation in this world of software integration, turns out to be your enemy. Abstraction is cheap when I'm doing objects, but when I'm doing this other thing, this building systems out of software, that abstraction turns out to be a heavy tax. It's expensive. And it's taken a while for the industry to come around to figuring this out. And there's been lots of stupid debates on the internet and in working groups and all kinds of places. But there are some observations which we can make, which you can actually go verify yourself, which I think will show that abstraction is not without price. And let's talk about what those are. Time makes abstraction expensive, right? If I put an abstraction out in space and require you to understand that abstraction and work against that abstraction, I now am committed to holding that abstraction consistent for a very, very long time. And nothing illustrates this more than COM. My beloved COM that has sent my children and my grandchildren to college in perpetuity, right? COM was very, very good to me, right? COM took a baby step towards saying abstraction was expensive, but it still didn't go far enough. Because the problem was, if I published an abstraction in COM, and COM was really about having a publication mechanism for abstraction, that abstraction was pretty brittle. And the problem was, people took their object-oriented viewpoint and said, I'm going to develop more and more interfaces in COM, and they're cheap because I got an IDL compiler, and I got a TLB, and I got an OICF marshaller. Hey, there's no cost, right? I'll just whack those guys in the registry. When was the last time you brought up OLAView? Right? Go look at OLAView and look at under interfaces. In retrospect, COM would have been better off. We might still be using COM had Microsoft had the common sense to not ship the IDL compiler. back in the dark ages of COM, prior to Windows NT 3.5, there was no IDL compiler. COM developers couldn't define custom interfaces. That is, if you did, they wouldn't remote. And we didn't give you very good tools for defining those interfaces. And if you wanted them to remote, you had to do some nasty ass stuff. Some really horrible stuff that even me in my prime, kind of got nervous about, right? When I was like really Mr. V-pointer and V-table, even me, who loved that stuff and didn't have a real job so I could actually devote my life to it, I wouldn't want to do that stuff, right? But COM decided that it would be good for people to define new abstractions, so we gave you the rope and you hung yourself, right? The rope was the middle compiler. We made it easy to define new abstractions, and those abstractions became your enemy over time because you had to live with them forever. And changing them was a royal bitch, as everyone who worked in this field knows. Yes?
So that doesn't seem to be saying that the pressing the abstraction is
Even if the COM had some physical issues, right? It had some physical liabilities with the way it was built that made changing abstraction expensive. But even in the absence of that, even if we didn't have UUIDs and V-table offsets, the introduction of an abstraction still takes time for people to understand, and getting that abstraction to be held constant is very hard. Ask Dave, right? Dave's got this albatross around his neck called RSS. Dave ultimately at some point back in 98, 97, whatever you did at the initial version, Dave basically got out of bed and said, I think this would be a good idea. Wonderful, I applaud you. You enabled all kinds of goodness to happen. But and I say this in only the nicest and loving way, the arbitrary decisions you made when you rolled out of bed that morning, the whole world is living with. Right? And yeah, it's not just about the format. It's about what the format means. For example, in RSS, what does the link element mean? Right? I mean, no offense. I mean this, Dave, nothing but respect and kudos for you.
actually Dave Netscape is valid.
Fine, great. Yes, the problem is trying to get people to agree on these abstractions is not even about the format or the physical goop, it's about the semantics, right? And trying to introduce new semantics is hard, right? And objects made it easy to define new semantics, and you had some way of managing the complexity because in general you were soldering them together and you could test the things you were soldering.
So that's like the number of dependencies you have. That's what you're saying.
Yeah, exactly. That abstraction is great within a given integrated circuit. But if I'm actually going to integrate Dave's software with your software, the more abstractions that have to be shared in common and that I have to get you both to buy off on, we're just FUCK'd, right? The more of those there are, the worse off we are. There's another problem, which is the one that everyone knows, but I just have it here for completeness, which is distance makes abstraction expensive, right? Abstractions which work really well in the in-memory to distributed systems, to message passing systems, yada yada, right? This is the lesson of DCOM. I'm required to put it here just because it's going to be in my book. You know this one, ignore it. You'll skip past pages. Cool. This one's fun. Extensibility makes abstraction expensive. There are two popular languages, Java and C#, that are kind of the ones that seem to be vying for a particular developer audience, right? And one is better than the other. You know which one that is. I don't need to tell it to you, right? Doesn't matter, right? Quality will win out. Whatever, right? Whatever. That's all just be. But they both made a horrible mistake. Both languages, both Java and C#, which were independently developed, by the way. I don't know if you knew this. Made a mistake. They allow me to do this, and this is a very nasty piece of thing to do, which I'm going to do right now. Is that better? Okay.
that you didn't use Notepad today, Don.
But I have to use Emacs. Bob.cs. Public class Bob. Public F whatever. Will that compile? How many people think it will compile? How many think it will compile in a Java compiler? How many think it will compile in a C# compiler? That's a coincidence, by the way. Right? I am shocked that there's any similarity, but whatever. This should not compile, or at the very least, it should give you a terrible management sign-off that requires your supervisor to come by and bless the code. I have just introduced unbounded extensibility into my system. Now, if you compare C# to Java, C# a little better in this respect, because the default for methods is non-virtual. That is, I know what I'm getting. Introducing this abstraction does not mean just J-random guy can come along and change it or reinterpret it. But of course, the fact that the class is not final or sealed by default is a mistake, right? That should have been the default, despite what my good friend Chris thinks. You know, he's entitled to be wrong once every 3 years. It should have been sealed by default. Extensibility makes abstraction expensive. Nothing proves this more. I mean, this is just one of these religious arguments. But the one that actually bears it out is MTS and Com+. Right? Do you know that there's this wonderful, rich mechanism for building interception and doing AOP-like things? And I know that Ted's in the room, so don't get pissed at say AOP on context here. But things that are faux AOP, right? AOP before AOP was known.
You saved that.
Thanks. There's this amazing extensibility hook where we can walk up to your code and do all kinds of shit you never even dreamed of. Right? It's really cool. And you know what? We never docked it. Right? The extensibility model for Com+ and MTS allows us to add all kinds of new interesting services and abstractions to your code. But we never docked it. You know why? Because we could barely get it to work with just our stuff. Right? The cost of abstraction, when you have all of these interesting interactions in a very fine-grained, tightly coupled system, is extremely hard to manage. And this facility, which we did in MTS and Com+, was deemed too powerful, and we didn't know what the ramifications would be, so we never docked it. And in fact, in .NET, right, we have this thing called the context architecture, which is undocked. Right? All we do is we have this thing that says, this is for us, not for you. Right? It actually says something like that on the doc page for each one of these. And there's no explanation of what it is. And by the way, we're going to kill it. Right? If you're a customer right now using the .NET context architecture, we will keep it working forever, but it's a dead end. Right? We basically did it so we could implement the interop with MTS and Com+, and mistakenly didn't mark everything internal. We should have never let that stuff out. Because the model is just too powerful. Unbounded abstraction in a system that you don't control, where people can walk up to the code and munge what's going to happen, is just a nightmare. Horrible, horrible, horrible. Then finally, abstraction is expensive when we're doing integration because of standardization. Right? Dave, again, wonderful. There's so much to be learned about industry in this field from looking at Dave Weiner, both the things he got right and the occasional time being wrong. And ask Dave about the cost of standardization. Right? The tax of getting 2 from every company to get on the Ark and stay on the Ark for 3 years is an incredible tax. And the more abstractions you try to get 2 from every company to agree upon, the worse the result will be. Nothing illustrates this more than XML schema. XML schema is the quintessential example of what happens with a design by standards body specification. rather than taking that was done and that experience with and effectively dotting the I's and crossing the T's, you had two from every company off doing wanton innovation and invention without implementation experience. And it was a train wreck in the making, especially when you consider the fact that you had people who vehemently disagreed about what they were building. Some people thought they were bringing object orientation to XML. Some people thought they were bringing database schema concepts to XML. Some people thought they were just, reliving the SGML dream. And so what do we get? We get a Frankenstein's monster that is dumber than the dumbest person in the committee. Right? No one person on that committee could have produced something this bad. It took an army of people to work hard day and night, to labor, to build something that is not good. It's not terrible. Can we make it work? Yes. But it's going to take a lot of work from a lot of plumbers and a lot of tool vendors to make XML schema palatable to the average developer. Right? Enough said. Right? A great example of the opposite approach is RelaxNG. It is widely believed at this point in time that RelaxNG is a better schema language for XML than XML schema. Why? Because two guys who were really smart said, why don't we go do this? And let's get it working, and let's build it while we do it, and let's iterate and see what works and what doesn't work. And then when we're done, we will take it to the Oasis, where they will carefully vet every decision and bless it and give it UN status. Good example of standardization, which is do all the work up front, and then at the very end, to make Mr. Safe feel good about it, let Oasis or some body like that go do it. The last thing you want is a standards body with an agenda. The last thing you want is a standards body with a charismatic leader who wants to go off and do a science project and have lots of innovation and have an incubator for new technology that's not driven by products, that's not driven by actual engineering. And so standardization makes this stuff expensive too.